Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. I hope everyone is doing well. So we have to continue. We continue our lectures on still under mass moment of inertia. Still under chapter Planar Kinetics of a rigid body, force and acceleration. Since we have finished the theoretical of uh, parallel axis theorem, now we have to solve a problem or two problems. Uh, how to find the mass moment of inertia of a composite bodies. So let's say we have a plate here. We have a plate here. This plate has a hole. Its density is 800 kilogram per meter cube. The thickness is 10 mm. Okay, the thickness is 10 mm. Alright. So we have to find or we have to determine the moment of inertia about n axis directed perpendicular to the page. Okay, so the axis is perpendicular to the page. Okay, and passing through point. Okay, and this axis pass through point G, first point G, and the second one point O. So means that it has two problems. You have to find the mass moment of inertia about about a axis which is perpendicular to the page, passing through point G and point O. You have two things to solve. All right. So if you refer to the table of mass moment of inertia, plate, this figures or this rigid body is similar that if you see the this thin circular this, so everything can be found from this mass moment of inertia. But the thing here is it has a hole. Okay, but here there is not a hole. All right. So what can we do is first. So if I zoom out this one, all right. So let's take the first one, which is the axis is passing through the G. All right. So it's similar to this. The axis similar to Z. All right. Okay. So if I draw it, uh, assume that this is the plate. So you have a hole here. Okay, you have a hole here, and then the thickness is 10 mm. All right. The radius without hole is 250. Okay, radius for this plate is 250 mm. The radius of the hole is 125. Right. So this is 125. So what you can do is you have to find the mass moment of inertia without hole. So you can say that we can do name it as I this. Okay, you have to find it first, and then you have to find the mass moment of inertia of the hole. So I put it here I hole. So the mass moment of inertia for this plate, okay, which is has a hole is ID. Okay, without hole minus I H. So you will got the answer of I plate for the example. Alright. So we see that for this problem, this is the axis mentioned in the problems. Mentioned in the problem perpendicular, the axis perpendicular to the page. Alright. So it's similar to this one. Perpendicular to the plate. Okay. So we can say that you can take directly this one is IZ. Alright, IZ. So if you refer to the equation of mass moment of inertia given, you got IZZ. Okay, IZZ means the IZZ is 1 over 2 mr squared. Okay, So ID here. So if IP is ID, okay, IP here is ID. What is ID? ID is 1 over 2 M RD square, okay, minus 1 over 2, okay, this one D, MD, sorry, minus M whole R whole. So what is M? Huh? Since we are given the density of the plate is 800 kilogram per meter cube, sorry, 8,000 kilogram per meter cube. So M is rho V, correct? So for whole, sorry, for this, rho is 100,000, sorry, 8,000 times V. What is the V? V is pi R D square times T or H, the thickness. Okay, so you'll find that MD is 8,000 times pi times RD is 0.25, H is 0.1. Alright, so you will get the answers here. Okay, we'll get the answers here. The answer is, let's say, you can calculate the mass of whole and this. So mass of the disk is basically 15.71 kilogram, while for M whole, okay, which is 8,000 times pi j or r whole square time h, which is 8,000 times pi 0.125 square times 0.1. So the answer here is 3.927 kilogram. All right. Now you can solve the problem of I plate, which is 1 over 2. The mass of the disk is 15.71 kilogram. R square is 0.25 meters square. Sorry, minus 1 over 2, 3.97, 27 times 0.15 square. Then here basically your answer is here the answer is 0.09 minus 0.0307, okay, or 0.4909, and then the answer is 0.4602. Alright, you got the answers, yes. And the mass moment of inertia of the plate where the axis is directed perpendicular to the page and passing through point G. Okay, the point G. So the answer is 1.46002 kilogram per meter. That the mass moment of inertia of the plate. All right, we have to continue our uh, discussion on this problem in the next video. Thank you very much.